Hi there, in this video I'm going to talk to you about the identity matrix. Okay, so let me title this Identity Matrix. So let me underline this. So basically an identity matrix is a square matrix. So it's a square matrix. So remember, square matrix means the number of rows equates to the number of columns. So the identity matrix is a square matrix where only the elements along the leading diagonal are 1 and all other elements are 0. So let me explain to you what we mean by the term leading diagonal also. So an identity matrix is a square matrix where the elements along the leading diagonal are 1 and all other elements are 0. So let me underline identity matrix. Let me also underline the fact that only the elements along the leading diagonal are 1, all other elements are 0. So let me explain. So in the 2 by 2 case, let's underline this. Now, for the identity matrix, we use the letter capital I. So capital I denotes the identity matrix. And in the 2 by 2 case, remember it's a square matrix. Okay, so for the 2 by 2, 2 by 2 means, of course, number of rows is 2, number of columns is 2. But I say that the elements along the leading diagonal, now leading diagonal is the diagonal in this direction. So we call this diagonal the leading diagonal. Okay, so only the elements along this diagonal, the leading diagonal, are 1s. All other elements are 0s. So this is the identity matrix for the 2 by 2 case. So this diagonal is the leading diagonal. They're all 1s. All of the other elements are 0s. Okay. Also, just as an added note, we call this the leading diagonal. The opposing diagonal, this is what we call the lateral diagonal. So the diagonal that I'm outlining in green, we call this, or this is referred to as the lateral. So lateral diagonal. So leading, lateral. Okay. So going back to the concept behind the identity matrix, only the elements along the leading diagonal are 1s, all other elements are 0s. So that's the identity for the 2 by 2 case. So for the 3 by 3 case, for example, let me write down the identity matrix. So 3 by 3 refers to 3 rows, 3 columns. So only the elements along the leading diagonal are 1. All other elements are 0s. So this is the identity matrix for the 3 by 3 case. Okay, and the same concept holds for any square matrix of any dimension. So for the 5 by 5 case, say, so the identity matrix, so remember 5 by 5 means 5 rows, 5 columns. So only the elements along the leading diagonal are 1s, all other entries are 0s. So it's going to be 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1. So as you can see, this is the 5 by 5 identity matrix, and once again remember, only ones along the leading diagonal, all other entries zeros. Okay? Now, let me make a note with regards to the identity matrix. So let me continue on the reverse. So here's a note. Let me underline this note in red. Now, when it comes to the identity matrix, if you multiply a matrix A by the identity, okay, that is the same as multiplying the identity by that matrix. Okay, so if you multiply A with the identity or the identity by A, you're going to get A again. Okay, so this is the condition when it comes to the identity matrix. So multiplying a matrix by the identity or the identity by the matrix gives you the original matrix A. Okay, so that is a condition worth noting. So that ends this video on the identity matrix. So I hope you found this video helpful.